Good morning, Devin. Good morning, CT. I love that picture of the Washington Monument. You know, I'm from DC, so I love to see local photos. I see Kayla is also here. Hello, Kayla. Trevor, how's it going? Thumbs up all the way. Kayla, how's the computer?
Sorry, it's much better. Sorry about my house. We're renovating my living room, so everything's a disaster.
Don't worry, don't worry. I've gone through renovations myself, and I know it's like it's a whole thing.
Yeah, yeah, I'm
we've all been there.
exhausted.
Yeah, totally. It's like a full-time job. I see Devin is here. Hello, Devin. And Angelo, how's it going? Enjoying the Northern Lights? Andrew, how are you? I love the picture because I feel like it's very spring, you know, and a lot of the country's moving into spring now, so that makes me happy. And then, of course, as always in San Francisco, beautiful this time of year.
That's just a background. I'm in Arkansas.
Well, you know, one man's San Francisco is another man's Arkansas. All right, we got Eric. Here's here. Hello, Eric. Hello, Hector. How are you? It's Thursday. I'm very excited. So the question here is, I had a little question to start off, and I want to know, what is a good movie that I can watch this weekend? Ooh, Labyrinth is a good one. Now for Chelsea's actually probably teaching her own class right now. So I should say, Chelsea, oh geez, how do you spell Rick Moranis' name? I can't even remember that. Rick Moranis, yeah. Or the Jack Nicholson version. Pulp Fiction, that's a great one. Scott Pilgrim, what is that one? I feel like Scott Pilgrim versus the World. Yes, excellent movie. Really, really good movie. Definitely a top 10 movie there. Yeah. Caddyshack, a good fallback. I wonder if Caddyshack stands the test of time. Yeah, Interstellar, another good one. I really like that film as well. Chelsea's, of course, saying Rick Moranis, which is the correct answer. Awesome. Any other recommendations? I got to be honest, guys, I've seen all these movies. Something new? I see Carlos is here. Zuneda, how are you? Kaji, how's it going? The Little Things. I haven't heard of that. I'm going to check that out. The International. I haven't heard of that. Willy's Wonderland. I haven't heard of any of these. Okay, good. Oh, with Denzel. Is that one of the ones where Denzel is just like kicking everyone's butt? I just saw a new one with Denzel. Is that The Little Things, where it's like there's a killer and like he makes the other, excuse me, I don't want to tell the end. Is that the one, Hector? Yeah, I thought it was okay. That was pretty good. It was good. I had to watch it in like 2 sittings. Ooh, The Lovely Bones. That's a great one. That is very much like a love song to Appalachia, which I thought was good. Yeah. The Trial of the Chicago 7. I haven't gotten into that. I feel like it's pretty heavy. So, but it's definitely on my list. All right. So let me share my screen with you all. All right. There we go. Kayla, I see we have a VIP today. Oh, I'm so excited. Everyone wave. Kayla, is that your daughter? What's her name? I love this. I think the greatest thing about Lambda, is that you can do it with your,
Oh, this is Jasmine. Yes, she's my second.
Hi, Jasmine. I love it. It's important, as a data scientist, starting young is always a good idea. I love it. Fantastic. I'm so glad that she can be here. Thank you for letting her come. All right. So let's dive into today's lesson. Let's get started. And today's lesson is going to be called, it's called Logistic Regression. And if you remember one thing from today's class, it's that even though it's called Logistic Regression, even though it has regression in the name, Logistic Regression is for classification. So keep that in mind. Now, I bet you guys are asking, wait, regression, linear model? How can you use a linear model for classification? Well, I'm going to tell you about it, but the short answer is you use an activation function. So remember, logistic regression, classification. Why? Because we use an activation function. So this is where we'll be focusing in terms of our ML workflow. We'll be talking about a new way to split data. And since we're going to be working with classification, we'll be talking about a new way to set a baseline for your model. And then we'll talk about building the model itself. Our goal here is we want to look at a kind of famous or popular data set called the Titanic data set. And we want to build a model to predict passenger survival on the Titanic. And in order to do that, we're going to have to do a couple core learning objectives along the way. Namely, up until now, we've done a train test split, but now we're going to do a train validation test split. So we're adding an extra split in there. Lots of splits. I hope you all stretched. And then the other thing we'll need to do is determine that baseline for classification. And then finally, we need to use scikit-learn to fit a logistic regression model. There's a little bit more to it, though. Let's see here. The first thing that I want to talk about is I want to talk about pipelines and how pipelines can help streamline the work that you do when you put transformers and predictors together. We're probably not going to talk about hyperparameters today, since we talked a little bit about it yesterday. We're just kind of let that information kind of percolate in the back of your minds, and then we'll come back to it in Sprint 2. And then I want to talk a little bit about plotting coefficients, like we did yesterday. And then I want to talk about why you do a train validation split. And then finally, let's kind of think about, I want to move from regression to logistic regression. So I want to take what we've done with regular regression and then kind of twist the way we think about it using that activation function so that we can get to classification. And then we should have time to talk about the module project as well. Okay, now before I jump into all of the content for today, I did want to talk to you guys for just 5 minutes. I wanted to wrap with you all for 5 minutes about what we talked about at the end of yesterday's guided project. And one of you asked, is it okay to feel a little bit overwhelmed, like you're drinking from the fire hose? And I said, absolutely. And you know what, when I was thinking about that this morning in the shower, that's right, I do take showers. It reminded me of a lot of the teaching that I did back when I was a language and literature professor. So like when I was teaching students Spanish. So I'm going to, if you will, just indulge me for a second, talk about that kind of overwhelming feeling, but in kind of metaphorically, in the context of learning a language. So on the first day of Spanish class, everyone comes in, they're all nervous, and then the first thing that I always teach students on when we're learning a new language or learning Spanish, I teach them a couple things. I teach them things like hola, buenos dias, right? Good morning, adios, goodbye. And then I also do things like, for example, ¿cómo estás? How are you? Estoy bien, I'm okay. Estoy más o menos, I'm more or less. Estoy mal, right? I'm good, I'm okay, I'm bad. I usually teach them those 3 phrases, just a handful of phrases to kind of get started. Now, there's a lot behind a phrase as simple as estoy bien, right? I'm okay, I'm good. like, for example, in Spanish, there are two verbs that you use for like I am or you are, right? There's a ser, there's a estar. They are irregular verbs, so you don't conjugate them in the way that you conjugate a lot of the other verbs. Oh, and by the way, in Spanish, you conjugate verbs, right? So there's all sorts, and by the way, that's the present tense. There's also the past tense, I was good, or the future tense, I will be good. There are all sorts of things that are behind that simple little statement. And a lot of times what happens when you start learning a language is you think that you need to understand every little detail about those words before you can start to use them, or before you can start to say to yourself, hey, I'm learning this, I'm getting this, I know this. And the truth is, actually, you need to think about it a little bit more functionally. It's not about knowing every little thing about that verb and all the grammar behind it. It's really about when someone asks you, hey, how are you doing? You can say, I'm okay. And so you can use it functionally in a conversational atmosphere. And all of that other stuff, it comes, but it comes with time. And so learning is not necessarily, we're talking about linear models, learning is not necessarily linear, where you get one chunk of information, you understand everything, and it's only then that you can move on to the next piece. Learning is much more of, let's think of it as a spiral, or an upwards moving spiral, where you start small, you work on a topic, you get to a certain level of understanding, you learn some other things, and you come back to that same topic, and you're a little bit higher than you were before. And then over time, you build up your, in the case of a language, fluency, or in the case of a coding language, well, your coding chops. And so a lot of times when you're learning something new, or like when I'm learning something new, especially when I was learning data science, we think like, oh, I don't get this. Everyone else is getting this but me, right? And that is actually not the case. The case is that it's okay to, for example, when you first start out, you know, kind of like the code that we're working in class, I know that this code goes here when I have that sort of problem. I don't exactly know everything that how this code is working. I don't know every little piece, but I basically know I take this chunk and I put it here. That is not, I don't get it. That is, I am learning. And so what I would say is when you're feeling overwhelmed, check yourself and say, well, am I feeling overwhelmed because I think I need to understand everything? And if that's the case, then the next question you should ask yourself, you should ask yourself is, well, what is the task I'm being asked to do? And can I get that done, right? And then realize that that deeper level of understanding, you know, that you see me and CC kind of throw around so casually is really something that comes over in time, all right? So again, overwhelming is kind of a natural part of the process, but don't think that that means that you will always feel overwhelmed, right? That's what learning is all about. We all kind of improve as we go. All right, so with that in mind, let's now move here to the notebook that we're going to be working on. And I actually have two links for today. And well, actually, before we do that, just another thing. Actually, I'll talk about this at the end of class. Never mind. So what I would like us all to do is I want us to go to the notebook that we used yesterday. So this is the first link, notebook number 1 that I included for you guys. So it should have yesterday's date and say 213. So everyone just give me a thumbs up when you have that notebook in front of you. All right, thank you, Devin. Anyone else? Thank you, Eric. Thank you, Hector. Angelo, much appreciated. All right, so let me just run this whole notebook. I'll just go up to runtime and I'll say run all. And what I'll do next is I will scroll down here. We have our wrangle function. We have our data here. We do our split. We established our baseline. This is where we are, where we're fitting the model. Okay, so now that we're talking about fitting this model, let's return to the conversation we had yesterday regarding transformers and predictors. I'm going to share with you my whiteboard screen, and hopefully it'll come up. Let's see here. There we go. And what we talked about yesterday is that when you have like data that isn't perfect, either maybe it has missing values in it, or it has categorical features that need to be encoded numerically, you can't just pop it directly into your predictor. And here's this predictor. And in this case, this was our linear regression model. So you can't just go all the way from your training data, your big X and your little Y, and just pipe it right in directly to your predictor. That won't work. So what you do is you take a transformer. For example, yesterday we used a one-hot encoder. And you first pipe your data into the transformer, you get the new data or the transformed data, and then you pipe it into your predictor. And actually, when you're working with more complicated data in the real world, oftentimes you need multiple transformers. So for example, another very common transformer, and I'll start labeling these transformer 1, transformer 2, another very common transformer is something called a simple imputer. And a simple imputer helps fill in missing values, so those NaN values. And so your workflow would be something more like do one transformation, do another transformation, and then finally put it into your predictor. In fact, we saw that yesterday with our select k-best. We did one hot encoder, select k-best, and then our linear transformer. Or I'm sorry, our linear predictor, our linear regressor. Now, you can imagine that this gets pretty complicated because here you have, X train. Here you have XT train, and then you maybe got to do XTT train. And before you know it, with all of this typing of variables and new variable names, and by the way, this is just the training data. You also got to do this to the test data. You can imagine that somewhere in these steps, you are going to mess up. You're going to type something wrong. You're going to forget to do something, and your whole model is going to come crashing down. You're going to get an error. And the folks who do scikit-learn know that this is the case. And so because this is the case, whoops, hold on. Because this is the case, they've created something called a pipeline. And what a pipeline does is it takes all of these objects and it puts them together into one object, into kind of one package. And that way, everything is in kind of like one bundle. You can easily save it and use it later. And you also don't need to worry about doing all of this renaming of things where you're inevitably going to make a mistake. Because let's face it, we're humans. Humans make all sorts of mistakes. So that's the conceptual idea behind a pipeline. Let me show you how to code it up. Now, before I do any coding, let me ask you guys a question. Any questions about what we've done so far, just what I've talked about generally? Any comments, things that people want to add? All right, so what I'm going to do is I'm going to scroll up to the top of my notebook and I'm going to import a new module. And it's going to be from, let's see here, LMNOP. So I'll do from sklearn.pipeline. And in fact, it's called a pipeline. import make pipeline. So this is going to be the first step into organizing my model. And then what I'll do is I'll scroll down here to where we had our previous model. And I'm going to just redo our linear regression model. So I'm going to call this model LR. I'm going to give it the same name, but instead of putting in the predictor, I'm just going to put in make pipeline. And then from there, what I'll do is I'll put in the steps that are going to be in my pipeline. So in this case, I'm going to put in my one hot encoder, and I'll do use cat names equals true. And then the second thing I'll put in is my linear regression predictor, which I'll just keep as it is. And here, all I'm doing is I'm separating them with a comma. All right, so what's going to happen is in this pipeline, everything's going to be acted on sequentially. So first we'll do the one hot encoding, and then we'll put it into the linear regressor. So what I can do is I can now just delete all of this stuff here. And I'll delete the linear regressor here. And now let me refit our model. So I'll do model LR dot fit, and I'll do X train and Y train. Notice that there's no XT train, there's no transforming the test set. It's all right here. And if I hit Shift and Enter, notice that I can see, here's my whole model. And inside this model, I have steps, and those steps have a square bracket on either side of them. So what do we call it when we have items assembled together and there's square brackets on either side of them?
List.
Exactly, it's a list. And then inside this list, we have two items. So we have one item here and the other item here. And notice that these are also a bundle of items, but instead of square brackets, they have parentheses around them. So what do we call that when we have an assemblage of items, but with parentheses?
Tuple. A tuple.
Exactly, a tuple. Some people say tuple, some people say tuple. I actually have no idea how you're supposed to say it, right? And a tuple is just like a list, except it's a little bit less flexible, so it's a little bit more permanent. But the important thing to remember here is that inside each of these steps, we have a name for the step. So for example here, this is just called one hot encoder altogether, all lowercase. And then we have the actual one hot encoder object itself. And same thing for linear regression. We have the name, linear regression, all one word, all lowercase, and then we have the object itself. And so this is all in the pipeline. And then what I can do, if I go down here to where did I look at the check metrics? I'm going to just delete some of the stuff we did yesterday. There we go. What I can do is I can remove this XT train and this XT test. I no longer need to worry about transforming the test data. I'm just training with my training data, and then the test transformation will be automatic, and you'll see that I get the exact same performance. All right, questions so far? All right. So Curtis is asking, if this process breaks because you did something wrong, how much harder will it be to debug? It's going to be about as equally difficult to debug as doing it outside. And what I'll do is at the end of today's class, when we look at how to do this guy right here using a pipeline, I'll show you how you can debug it. Great question. Let's just do one more to kind of cement it here. Let's do this longer one where we had the one hot encoder, the select k best, and the transformer and the linear regressor. So let me create a model. I'll call it model SKBLR, so it'll have the same name. And I'll do make pipeline. And then inside the pipeline, I'll do first my one hot encoder, and I'll do use cat names equals true. Then I'll put in my select k best, and I'll select k. I'll put k equal to 20. Now, here's a question. When we talked about k yesterday, we had a term that we used for it, a term for a knob that a data scientist adjusts before the fitting process that will influence the fitting process. What was that word that we used? Curtis, you're quick on the keys today, right? It's a hyperparameter, exactly. So I've set that hyperparameter, and then the last thing I'll do is I'll do my linear regression. So there I have all of this code is now here in this little package. And instead of doing model, SKB, fit, XTT train, I can just use my regular old training and test set. And if I hit shift and enter, it trains, and we can see here is the pipeline, and it's the same layout where the steps are in a list, and then each step is in the form of a tuple where we have the name and then the object itself. You may be asking yourself at this moment, Nicholas, if this is so easy, why on earth did you make us do it the hard way yesterday? The answer to that question is I'm a very cruel person, as you guys can see. The real answer is, though, that I wanted you guys to get a little bit of an intuition about how these transformers work before we kind of refactored them and put them just inside this pipeline. So I wanted to get a little bit of idea of how they work before we swept them under the rug. So there is a method to my madness. All right, any questions?
So when you're calculating the mean average error for each of these models, how do you pull them out?
Mm-hmm. So you don't need to change anything. The metrics are going to be calculated the same exact way. So for example, here is the mean absolute error. And the only difference is instead of putting in my transform data, I can just put in my regular train data and my regular test data. I don't need to make those transformations ahead of time. It'll happen as part of the model process. So if I hit shift and enter here, I can see here's my performance. So in terms of looking at these metrics or calculating these metrics, you're not going to make any changes.
Does it only bring back one value, or is it, do I have multiple values? Do I have one for the SK and one for the one hot encoding and one for linear regression?
So it's only going to give you, that's a great question. So you are only going to see what you put in and what comes out. So if in this case where we have two transformers, I'm sorry, this is not a beautiful picture. We're not going to see all of the different transformations of the data that happen here and here. All of that is going to be refactored for us, so we don't have to worry about it. We just know what we put in and we know what we get out. So we'll put in our training data or our test data, and then we'll get out a prediction.
So
Now-
I would need to create multiple pipelines if I want different, if I want to use different transformers.
If you wanted to try different combinations of different transformers, you would need to use different pipelines, sure. It gets, I mean, you guys can imagine it can get pretty convoluted pretty quickly, but this is kind of, that's the basic answer, yes. One thing that you do need to keep in mind when you're doing all of these transformers is you can have as many transformers as you want, all right? But you can only have one predictor, and it has to come at the very end. So many transformers, but one predictor to rule them all. Okay, other questions? I love how you guys are thinking about all the little pieces to this. By the way, we also have Slido. Here's another question in Slido, which I'm going to answer. How do I know I did okay on the daily module projects that I submitted on Monday, Tuesday, and Wednesday? Great question. For Unit 2, the module projects are a little bit more free form, but what you should know is that if you can get through the check for understanding questions, then you should be all right, okay? So we don't have the same level of evaluation that you see in Unit 1 because we're kind of opening up the, we're kind of taking the blinders off a little bit and giving you guys more freedom to experiment. But as long as your notebook runs from top to bottom and you're generating those predictions and generating results, you're in good shape. Okay, let's take a 5-minute break. And then when we come back, let's move on to logistic regression and all that good stuff. All right, see y'all soon. Okay, guys, come on back. Come on back, y'all. I'm excited. We have pipelines in our lives. Things are really going to start getting better. All right. You know, I feel like we could use a little bit of, I feel like there's a little bit of quiet energy here. We need to kind of get up and think about, we kind of need to move a little bit more. We need to increase the buena vibra in the room here. So here's what I want everyone to do. Make sure your camera's on if it's not already. If that's all right, if there's a reason you can't have your camera on, that's also fine. Okay, here's what I'm going to do. I am going to count to 10, and you guys have 10 seconds. I want you to find something around you that is yellow, and then bring it back and show it to the camera. All right, so you have 10 seconds to find something yellow. Ready? Go. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000, 7, 1,000, 8, 1,000. Oh boy, 9, 1,000, and 10, 1,000. Okay. All right, excellent. I see a lot of books. I see a dictionary of basic Japanese grammar. Excellent, Joseph. Rubik's Cube, fantastic. Andrew, I cannot see, what is that, a candy bar? Here's what I have. I have a little frog. There we go. Oh, Zanera, what is that? Is that, what is that? A bottle of,
It's a hot glue gun.
a hot glue gun. Are you a big craft person?
Yeah.
Okay, awesome. Very cool. Awesome. And then you've got the Post-its. I have those also, just in case. Great minds think alike. Very cool. All right. All right. I'm feeling like we're being a little bit, I feel like we have some good movement here. Excellent work. A bottle of lemonade. What a good way to start the day. Okay. What is that, Carlos? Is that a car? Oh, wow. That's one of those fancy model cars. If my father-in-law were here, he would be like asking you 100 questions. He loves model cars. I had to tear him away from the car museum when he came and visited in Los Angeles. All right, very cool. 59 Corvette, awesome. All right, let's do a quick warm up now as we move into this next section. I want to talk a little bit about, I just want us to kind of be thinking about some of these, activate some of this vocabulary. All right, I see that there are 16 of us here in the chat, so I feel like we can get 11 folks to answer the quiz. Now remember, the thing with these quizzes is not necessarily getting it right or wrong, but making a decision about what your answer is going to be, and then learning from that decision. All right, we already got 1, 10 more to go. Keep it up, guys. Okay, about a third of the way, about a quarter of the way there. Oh, now about a third of the way there. All right, over halfway. Come on, let's go. 3 more, 2 more. Oh man, we're killing it. Do you guys think we can get to 13? This would be huge. This would be a revolution. We've done it. Okay, way above our goal. 14, oh my goodness. Great work, guys. Okay, so let's take a look here and see what we are all talking about. I'm going to, let's see here. Let's start with number 1. So what is the worst R-squared score from the choices below? Now, generally speaking, we talk about scores going between 0 and 1, and generally 0 is bad and 1 is good, except with R-squared, there is that thing where it can be negative sometimes. So 0 definitely is bad, but -1 is really bad. There's probably something going on with your model, or there's some crazy overfitting going on there. Okay, beautiful. Great work, guys. This is really good. All right, let's look at number 2. Which is less affected by outliers? Is it the root mean squared error, or RMSA, and mean absolute error, or MAI? All right, let's see what it is. And it seems like we're a little more split on this. So which is less affected by outliers? Now, the key here to thinking about this problem is that, or this question, is that we're always comparing the difference between our true labels, y, or a true target, and our predicted target, which we'll call y hat. Remember, this is the prediction hat. And whenever you have a big difference, we have negative, sometimes we're above, sometimes we're below. So sometimes this number is positive and sometimes it's negative. And the way that we deal with that when we kind of want to add up all of these little errors is we, in the case of mean absolute error, we take the absolute value. And in the case of root mean squared error, we square that value. And when you take a big number, because maybe you have an outlier, and you square it, it becomes really big. And so which of these is less affected by outliers? Well, less affected by outliers would be the, let me come back here, hold on, would be the mean absolute error, the mean absolute error. Great work. So absolute error, those error terms don't become as big, but when you square them, they become big. So mean absolute error is a little bit more robust in that sense. All right. Rocking and rolling. I'm loving this. Oh boy, it took me a long time to put this screenshot together, guys. I'm not going to lie to you. Okay, if you use a one-hot encoder to transform this feature, how many columns would your transformed feature matrix have? By the way, if you understood this question, for me, that's a really big victory because we're already having new vocab in here. One-hot encoder, the idea of transforming, the idea of a feature matrix. So this is already a victory for me if you answered this question. So the results here are, how many would you have? It looks like the majority of y'all said 3, and you're absolutely right. We would have a column for low, we would have a column for medium, and we would have a column for high. So there would be 3 columns. Great work. And now it's time for my favorite. Write a tweet explaining the difference between a regression problem and a classification problem. Excellent. So let's see here. Let me start at the bottom. All right. A couple people saying they're not sure. That's fine. That's why we're here. Here's one that says a regression problem solves for discrete continuous targets, like, for example, rent. Rent is between 0 and, I don't know, $1 million a month. And a continuous classification is for not necessarily Boolean or binary. That is true, yes or no. It could also be multiple classes too. It could be yes, no, maybe. So for example, going to our rent example, a regression problem would be, what is the rent going to be on this apartment? I'm trying to predict a number between 1 and a million. What is a classification problem? Is this apartment going to be rented in the next 6 months? Yes or no? Will the tenant who rents this apartment be a skateboarder, a bocce ball player, or a basketball player? Those are 3 discrete variables. Excellent. So classification has different non-numerical values that need to be set into numbers. That's true. Regression has numbers. I like that. Regression is using continuous values, while classification is more with Boolean values. That's right. It could be yes, no, 0, 1, survived or didn't survive. It can also be multiple as well, multiple class. I love this. The target variable for a regression problem is continuous. And then the target variable for a regression problem is a categorical variable. This second part I don't quite get. Let's see here. One is categorical and one is numerical. Sure. Regression is about predicting numbers. Classification is about predicting type. I like that. I like that. I might even say, I would do one little tweak. I would say is about predicting class. I love it. This one I really like here. Regression problem has a continuous target. A classification problem has a discrete limited categorical target. That's really good. A regression problem would involve numerical data, whereas a classification problem would involve categorical data. I love that. Here we have classification as a binary result. And we said, well, it could also be multiple classes, but definitely true. And then a regression problem is predicting a quantitative variable, where classification is about categorical variables. I love it. I love it. These are all really, really good. Beautiful work. Excellent job, guys. Excellent work. So we have now this good grasp of the difference between regression and classification. So regression is for a continuous target, and classification is for discrete target. Let's take all of that and think about how we're going to do our particular problem here. So what I'm going to do is I'm going to go to GitHub, and I'm going to go to the repo for this sprint, and I'll just paste that in so everyone has the link. And by the way, if you didn't hear, I have redone all of the assignments, so now they are correct. So the one that you all are going to be doing today is right here in the module for logistic regression. So let's see here. If I go to data, and I go to Titanic, this is where we're getting our data. Notice that we have a training set and we have a test set. So notice that up until now, we've been seeing just one file and we divide it into training and test. In this case, it actually comes to us in 2 separate files. So this has already been done. They did the work for us, suckers. Okay, so what we're going to do is I'm going to use a wrangle function here. And this wrangle function has a couple little things. First, there's a passenger ID column, and I'm going to set that to the index. And then there are a couple high cardinality categorical columns, which we're not going to use. So I'm just going to drop them. And what I'm then going to do is I'm going to just load, let's see here. I'm going to load the data frame first. I'm going to load the training set. So I'll do, whoops, I got an error here. Data path is not defined. The reason, why do you guys think I'm getting this naming error? Data path is not defined. What's this about? What do y'all think?
I'm not sure, but I've had this issue consistently with my notebooks, and I'd have to go back and even look how I did it. I'm not sure, but
Okay.
I'd run into this every single time.
All right, excellent. Well, this is
Not a
good because we're
workaround.
running
I
in.
just couldn't verbalize it.
Yeah, fair enough, fair enough. Okay, well, let's think about this. Data path is not defined. Well, first, let's think, what is data path? All right, well, data path is a variable, and I see Devin, I think you're on the track of the solution here. Data path is a variable, and in order for our computer to use a variable, we need to actually set it equal to something. So right now, for example, if I open up a new code here and I do type, and I type in data path, what it's going to tell me is, I'm sorry, what is this? There is no type. What is data path? There's nothing called data path. Where did you define this variable? So Andrew and Devin, y'all are on the right track here, which is I didn't run this first cell. And here it's in this first cell where I define data path as a string, which happens to be like a URL to this repo. So once I run this, then what we'll see is if I come back and I look at type data path, I can see, now I have this string. Now I have this data path. And then what I can do is I can add things to it. For example, here, I can add this string to data path. So adding a string to a string. And what that does is it just concatenates them. It puts them together. And now I have an extra long URL, which goes directly to this file. So here's that same one. And here we can actually see our data. Here's the passenger ID, the names, the age, all that good stuff, their ticket. So oftentimes with these notebooks, you kind of get out of order, because it's easy to scroll up and scroll down. And then this is one of those examples where that can get you into trouble. And eventually you want to make sure that your notebook can always run from top to bottom without any errors, just in the way you would be coding if you weren't using a notebook. And so if I look at the data frame here, if I do df shape, I can see that I have a pretty small data frame. It's 891 observations, and it's pretty narrow too. I've got 8 features. And the beautiful thing about this wrangle function, this is one of these examples where a wrangle function is really going to save your bacon, is that if I want to do the same exact thing to another file, in this case, my test set, I can do that. And so, for example, if I run this cell again, and I can see I have df shape, and now I have df. Let's look at x test.shape. And I can see that this is a smaller number of observations, but also check this out. It has one less column. What do you think accounts for the difference between this 8 and this 7? By the way, Andrew put a really great tip in there about knowing whether you've defined something. And you guys are right, all right? So in my test set, there is no target. There are no answers because this is probably for a data science competition, and they're not gonna, you just build your model and you make your predictions and you submit your predictions, but you can't know the answers ahead of time. So they'll give you the training data, but you then need to use that training data to build your model and then make your predictions using the test data. And then you submit your predictions and they'll tell you how you did. And whoever does the best wins. And you guys are right. So I have that target. Let's just quickly look at the info here. I can see that we have survived, we have P-class, sex, age, we have this thing, which is where they, I'm not actually sure what this is. And we have some other stuff as well. Now, here's a question. Our target is going to be survived. So let me just look here at DF. And I have my target. Let's just look at the head here. And I can see that I have zeros and ones. So what do the zeros and ones represent in this case? Now, Andrew is saying that whether they survived or not, or Zunera, this is beautiful. Thank you, Zunera and Kayla, right? 0 is didn't survive, and 1 is they did survive. So we can almost think of survived as like survived with a question mark, and then 0, false, no, they didn't. 1, true, yes, they did. It's binary, exactly, Joseph. So this is a binary classification problem. Excellent. So we have our binary classification problem. And now what we need to do, we've done our wrangling, and I want to start doing some splitting here. So the first thing I'm going to do is I'm going to split our target vector from our feature matrix using the same code that we've used this week. I'm going to set the target to survived. I'm going to make sure my little y, my target vector, is going to be just that series. I'm going to have my big X, or feature matrix, be everything but that target. So now I'll have my X head here. So this is what my model will be using to make predictions. And this is what my model will be using to check its predictions. All right, beautiful. Now, here's the deal. You can only use your test set once at the end when your model is complete. When you're doing data science competitions, you can maybe make 1 submission a day or 2 submissions a day. So you can't just use the test set over and over again. 1, you can't do that for a data science competition, but more importantly, 2, the whole point of test data is that your model didn't see it during training, and you, the data scientist, didn't see it while you were creating your model. Because if you constantly look at your test set, then what you're going to start doing is you're going to fit your data to the test set. So maybe you're not giving your model the answers during fitting, but you kind of are indirectly, because you know the answers and you're trying to get better and better performance on your test set. The whole idea is that if you want to see if your model can generalize, it needs to be data that neither the model nor yourself have seen. So you can use your test set 1 time at the very end. Now this presents a problem, which is if I can only use my test set once, how can I check my model performance? Like, how can I check if it's overfitting like we saw yesterday, like whether I should use ridge, or how can I check whether my hyperparameters are correct? You know, how can I know what to set K to or what to set alpha to? I need data that my model doesn't see during training, but that I can see and kind of use in order to, you know, make sure my model is working correctly, or to use a synonym so that I can validate my model. And Curtis has come up with the solution. What I can do is I can take some of my training data and I can hold it back, kind of like I do with test data, except now I'm allowed to see it a little bit. All right. And don't worry, Curtis, we'll do the attendance after the next break. Don't let me forget, guys. Okay, so what you do then is you take your data, you take your training set and you divide it. And instead of calling it a training and a test set, you call it a training and a validation set. What's the difference between a validation set and a test set? The validation set, let's think about it this way. For a training set, your model sees it during training and you see it. For your validation set, your model doesn't see it during training, but you do get to see it. And then for your test set, your model doesn't get to see it during training and you don't get to see it either, all the way until the very end. All right. So what we're going to be doing is we're going to be taking our data and we're going to be our training data and we're going to divide it up into our training and our validation set. And so the way to do that is going to be a little bit different than what we've seen so far. Namely, if I look at my X right now, there's no time component here. So I don't need to worry about my training set being chronologically before my validation set or my test set. In fact, what I can do is I can do a random division. So I can maybe just pull numbers out of a hat and say, all right, this one goes to the training set, this one goes to the training set, this one goes to the validation set, this one goes to the training set, and this one goes to the validation set, and so on and so forth throughout the entire data frame. So in this case, where we need to do a randomized split, we can actually use a tool from scikit-learn. And let me open it up and share the documentation with you all. And in scikit-learn, we use this thing called the train test split. Now notice, by the way, this is called train test split. You can use it for dividing data into a training set and a test set, but in this case, we're using it to divide our training data into training and validation. So I've already imported it up above, right here. So I'm not going to import it a second time. But what I am going to do is I am going to do train test split, and I'll put in my feature matrix big X, my target vector little y. I'll then put in an argument, let's go here, for test size, Again, note that I'm saying test size, but this is actually going to be the size of our validation set. So just, I know it's a little bit wonky with the vocab, but just bear with me. And generally speaking, you want your validation set to be 20% of your training set. So I'll set that to 0.2. And then the last thing I'll do is I'm going to, let me go back to the documentation. I'm going to take this random state argument, and I'm going to paste it in here. Now, random state is all about reproducibility. What do I mean when I say that? Well, this is a random process. I am going to divide the data into training and test sets randomly. However, I want to make sure that this random process occurs the same way every time, so that if somebody comes to this notebook, a year from now, they're going to get the same results that I did. So my research is reproducible. And so the way you do that is you set a seed, or we just can call this a random state, to make sure that that random process happens the same way every time. And this can be any integer here. I can put 100, I can put 345. Generally speaking, though, data scientists like to set this to 42, kind of as an inside joke. Does anyone know where this joke comes from? This is extra credit. 42, what is the importance of 42? Oh, Ven, you got it. Exactly, Logan, exactly, Carlos, you guys have got it, right? It's a reference to Hitchhiker's Guide to the Galaxy. And if you weren't sure that there are a lot of nerds working in data science, now you know, now it's confirmed. This isn't a football player's number, let's put it that way, all right? So what I'm going to do now is this function, it actually outputs 4 different objects. So I'm going to do xtrain, xval, ytrain, and yval. So it basically gives you everything and you just need to assign it to the variable names. So I'll run it like this, and then what we'll see is, let me do another, let's look at the length of xtrain. We'll see the length of xtrain is now 712. If we add that, if we add the length of xval, we'll see that we get 891, and we know that that's going to be equal to what was our original feature matrix x. So it's done that subdivision, it's done that random split, just like we hoped it would. Any questions? Questions about what we've seen so far, either in the wrangle function or in our split right here, our double split? Great question here, more of a general question. How advanced should my Python be in this unit? I often get held back in expressing my thoughts with code in this unit, and it takes me a while to Google for tips. Well, I think that that is actually a very natural place to be at this point. My advice would be, my only advice is that when you're doing the module projects, don't copy and paste code from the guided project. Do your best to type it out and start building that muscle memory. And if you have to go to Google, absolutely. I mean, let's be honest, nobody codes without Google anymore. It doesn't matter how many times you've been doing it. And my advice is when you're working with things like, Google is one thing, Stack Overflow is a great resource. Also very important, have the documentation open. I always have scikit-learn documentation open when I'm working with it. Same with pandas. So that way I can quickly see the wonderful examples they have and also know exactly how these different parts of the library work. So Google is great. Documentation is even better. And when you're doing the module projects, do your best to code and not copy paste. Great question. Other questions? Oh, the Python Data Science Handbook, another great recommendation. Thank you, Curtis. I love the idea of getting a hard copy. The other thing you can check out is if you go to your local library, they often have access to things like the O'Reilly platform. So here's O'Reilly.com. And you can get free access to this platform, which has a lot of these books that CC and I recommend. You have access to them. So check your local library. I really like having hard copies because I am on the computer all day. And so not looking at the computer is a great change of pace for me. All right, before we go on break, I want to talk about establishing a baseline for our model. Now, last time, when we were looking at regression problems, we used mean absolute error to evaluate our model. And the thinking behind that was we created this idea of a naive model where it would always guess one thing, and we said it'll always guess the mean. This is a classification problem, however, so we kind of need to roll back our thinking and start from first principles. So if you could only guess one class out of our two classes, 0 for didn't survive or 1 for survived, which is the one that you would choose? So what would be your one guess between survived and not survived? Or how would you determine what that guess would be? Ven is peeping my text here. The majority are class, or Zanera is saying it in a little bit more of a layman's terms, right? The one which happens the most. So if we look here, how can we figure out which one is happening the most? If I'm looking at, for example, Y train, what do y'all think? I can do value counts. Okay, I love this idea. So I'll do value counts. And here I can see that 444 is, and this would be the mode. You're absolutely right, Zaneta. So I can see that 0 is definitely my majority class. And so here's a question. If I always guessed 0 for this data set, how often, what percentage of the time would I be correct? Around 2/3 of the time. You guys are right. Exactly. And you know what? There's an easier way to do this than just by doing it in the old head computer, the old meat computer. I can set normalize argument for value counts to true. And what that will do is it will give me not the raw counts, but the percentage. And so you guys are right. If I always guessed 0, I would be correct about 62% of the time. And if I wanted to just get this value, the biggest value, I could use dot max. So here is my baseline. And what I'm doing to call this is I'm going to call this my baseline accuracy score. So just like if you're taking an exam in school, other schools, not Lambda school, you get a score between 0 and 100, right? 0% and 100%. Well, it's the same thing, right? Or if we're doing it in floating point values, it would be between 0 and 1. So again, we see accuracy score goes between 0 and 1. Score goes between 0 and 1. 0 is bad, 1 is good. And in this case, if I always guessed did not survive, my accuracy score would be 62%. And so that's the baseline that I'm trying to beat. Okay, questions about accuracy? All right, let's take a 5-minute break. And when we come back, we'll do the attendance quiz, and then let's do some coding together. I think we would be well served by doing some collaborative coding. So see you all in 5 minutes. Everyone get up, stretch, have some water, come back ready to rock. All right, come on back, guys. Let's get rocking and rolling. Let's wrap this puppy up. Let's get moving and grooving. All right, I want to try one last Zoom game. So everyone get your cameras on here. All right, here's the idea. Nobody do anything until I say go, okay? That's the first thing. All right, this is called Zoom Vogue. What you're gonna do is you gotta throw your hands up, just straight up, and you need to get as close to the edges, like exactly to the edges of your Zoom window. All right, so you gotta vogue as close. Don't put your hands up yet. You can't look. You just need to like feel it out. All right, so you gotta do one like this, and then you gotta do one like this. So it's a vogue. All right, but you can't, Joseph, not yet. You can't cheat. All right, ready? All right, ready? 3, 2, 1, vogue. Everyone vogue. I'm terrible at this. I like it. Nope, I'm pretty. You guys were not. Zunaida, you win, obviously. Yeah, you've got it. Okay. Good. You can't go over. This is like the price of right. You can't go over. Yeah, Devin's got the way to do it. All right, good. So let's now start working on this data set and start building a model. What I would like to do is I want to do two things. The first thing that I want to do is I want to talk about why linear regression wouldn't work here. And I know that we have multiple features here, but I'm going to just look at one feature. I'm going to look just at age. And so let's think about this for a second. If I looked at X-train age and I plotted a histogram, we can see that the ages range between 0, well, not 0, but like, babies, all the way up to 80, with most people being in there between like 20 to 40 range. Now, what is your thought? How do you guys think age relates to survival or not? Do you think as you get older, are you more likely to survive? If you're younger, are you more likely to survive? What do you think? So Ven is saying kids and women boarded the rafts first. So the idea that kids board first would be thinking that younger would increase your chances of survival. I think that's pretty good logic. Let's plot this out like we would with a regression problem. So let's have age along the x-axis and then y along the y-axis. Age along the x-axis and then survival, yes, no, 0 or 1, 0 along the y-axis. So here's what we have. And it definitely looks like, to an extent, we see more people on the 0, we see more older people here. So I think what you're saying does make sense, Ven. But the next question is, what would happen if we plotted a regression line here? Our regression line would probably look something like this, because it's trying to get in between the different data points. So would this work? Would this model give us useful predictions? Why or why not? What do you all think? Is this a useful model? You guys are really making a lot of sense here. Curtis is saying no, because this is a classification problem. Number one, this line gives us continuous values. And this is a classification problem. We don't need continuous values. I need either a 0 or 1. The other thing is Devin's saying it's hard to be 0.6 alive, right? Kind of a similar related thing. And that's absolutely right. And, we can extrapolate this here. This line, even though it's pretty straight right now, at some point, it's going to go above 1 and below 0. It's a line. It goes on forever. And you can't be like negative 0.1 alive. You can't be negative alive or negative survived. And you can't be above 1. You can't be 1.1 survived. What does that mean? You survived and they made a movie about it? I don't know. So this line is not going to work, okay? We can't use this line for a regression problem. So the idea that you might be able to use one of these functions that we've been talking about, where y, which is survival, is equal to some sort of coefficient beta 0 times another coefficient beta 1 times some sort of feature, in this case age. The idea that this is going to give you a useful prediction is, quite frankly, preposterous. It's as preposterous as thinking that woman actually saved the heart of the sea gold diamond thing and then threw it into the sea after they went down and dived to it. I don't remember the plot of the movie exactly, but you guys get the idea. It's preposterous. All right? So what we need to do is we need to change this equation. We need to change this kind of linear regression thing so that it actually gives us what we want. So like CT is saying, we don't need, we don't need 0.6. We don't need these continuous values. We need yes or no, 0 or 1, or 1 or 0. So what we can do is we can do a little bit of math. And I don't really want to go into the math here because I don't think it's particularly helpful. Let's just talk about it kind of in abstract terms. What I can do is I can take this equation and I can wrap it in another function, right? So like this is a function. Well, let me wrap it in another function. And I'll call this a sigmoid function. And we don't need to go into the details of what a sigmoid function is, or the math, or what E is and all that stuff. But if I want to look at sigmoid function, let's just see what it looks like. Oh, here's a good one. Here's a sigmoid function. So we can see that it's this beautiful little S curve. And we can see that this S curve goes 0. It never goes below 0, and it never goes above 1. So it's bound between 0 and 1. And so in this case, our crappy line would suddenly look like something like this. By the way, this part in the middle, this is called the squiggle. That's not a technical term. Don't use it in an interview, but that's what everyone calls it. It's the squiggle. And so what happens now? Now my model isn't predicting -1 or +3. It's only going to give me values between 0 and 1. And those are all going to be floating point values. So 0.2, 0.4, 0.6, 0.8, etc. And then what I can do is I can create a cutoff. And I can almost think of those floating point values as probability that somebody survived, or rather, my model's degree of certainty that somebody survived. So my model's degree of certainty that someone survived. So if it's a 1, my model is 100% sure they survived. If it's 0, they're 0% sure they survived. That is, they're sure they didn't survive. And if it's 0.5, it doesn't really know. And what I can do then is I can have a cutoff where I can say, okay, let me choose a cutoff, and everything above that value, I'll just say survived. So once I'm above a certain degree of certainty, I'll say they survived. Like if I'm more than 0.5, if I'm more than 50% sure they survived, I'll just say they survived. And if I'm less than 50% sure that they survived, I'll just say that they didn't survive. We can almost think about this as, I like to call it an activation function. Do you guys, have you guys ever gone to the county fair? Has anyone ever been to a county fair where you have that thing where it's like, you have a sledgehammer and you bang the thing and then you try to get the little like ball to like go all the way up and hit the bell and you try to see how far you can go up? Does anyone know what I'm talking about? Has anyone ever seen this? Okay. All right. So I'm not, yeah. We've all seen it like in a movie somewhere. We can almost think of this as the same thing, right? Like this is an activation function. So we put in our information, and then what happens is we see, okay, how far up on this little curve does our activation go? Does it only go to 0.2? Oh, well, then we say it doesn't survive. Does it go all the way to 0.8? Yes, it does. Boing, let's say they survived. Does it go all the way up to 0.9? Yes, it does. You survived, you won. All right, so think of it as an activation function. We put in information and we see boing, how high up we can go on that scale between 0 and 1. Okay, questions about this kind of conceptual piece, the idea of logistic regression? Ven is asking, is the intercept included in the sigmoid function? What if we have more than one feature? Absolutely. So this little inner part of our function, the little first part of our function, the linear equation part, that's going to be like any other linear equation that we've seen up till now. So there'll be an intercept, there'll be, so there'll be a beta 0, and then for every feature, beta 1, beta 2, beta 3, beta 4, or x1, x2, x3, x4, there'll be a corresponding beta coefficient. So beta 1, beta 2, beta 3, beta 4. So we can take all of that equation and we can put it into a sigmoid function, and that will create that bounding. That bounding in that squiggle. So I can take any linear and just pop it in. Other questions? Now somebody's asking, how much of a difference is there between this and just rounding to 1 or 0? Well, I mean, it depends on the nature of the data. So if you do a linear regression problem, we can see that our model isn't really going to fit it. It's always going to be like 0.6. So there's not even really like you would round everything up to 1 by that logic. And so it's not really going to work. You really need to take that line, put it into that activation function and transform the way it operates so that you can't go above 1, you can't go below 0, and you can treat those values in the middle as kind of a degree of certainty. Great question. Other questions? Okie dokie. So we have an idea of how this works. And the next step then is we need to create a model. Now, before we create a model, let's just look and see what's going on here. Let's look at our X-train. So here's the head. And then the other thing I want to look at is I want to look at xtrain.info. So a couple issues that we have. First, look, we have here missing values. And I see your question, Curtis. Let me do a little bit of research and I'll get back to you after class, okay? So here we have missing values. That's a first problem. That's something we need to deal with. We can't have missing values and feed them into a linear regressor, or excuse me, into a logistic, into any regressor, right? So that's not going to work. And then the second thing is, what about just the data? Is this going to be able to work just by itself? Do we need to do any transformations here in order for our model to be able to train? So Curtis is saying that sex would need to be encoded, definitely. Anything else that we need to encode? I guess P class technically we would need to encode. That's fair. Fair point. What else? Also embarked. Actually, you know what we should do for P class? This is a great call out, guys. Thank you for pointing that out. Let's go up to our wrangle function here and let's change the data type so that P class is imported not as a number, but as a string. So that way it's actually you know, a proper categorical variable. So I'll put this in as an object. There we go. So I'll do D type and I'll pass in a dictionary. There we go. And then I'll just run all of these guys again. There we go. Very exciting. Okay, now P class is an object. Sex is an object. And then embarked is also an object. Okay, great. So we're going to need to encode those. Excellent. And then we're also going to need, for age, we're going to need to impute the missing values or fill in those missing values. So what I want everyone to do now is, if you're not coding along with me already, take this and click Save a Copy in Drive so that you can save a copy in your own drive and y'all can code along as we're putting this pipeline together. So let's do a little live coding together. And then just give me a thumbs up once you have your own notebook that you can work with. And by the way, make sure you do runtime run all so that you're ready to go. So just take a minute to do that. And let's do a little code along. I got a thumbs up from Andrew. Devin is ready. Eric, awesome. Van is on it. CT. Oh, I see Angelo, CC, Logan. Okay. Let's just wait another 30 seconds or so. Hector, thank you, Hector. All right, let's see here. Okay, let's get started then. So I want everyone to code along with me. I'm going to scroll up to the top of my notebook and just show you what I've imported so far. From category encoders, I imported our one-hot encoder, so we can use that. For imputing those missing values, I imported simple imputer, so we're going to use that. And then there's another transformer, which honestly, we don't need to get into the details, but what it's going to do is it's going to scale the data, which makes it easier for our logistic regressor to do its job. Oftentimes, if you use a logistic regressor, you should have a standard scaler in there as well. CC, would you mind putting in the links for simple imputer and standard scaler? You guys know I love my documentation. All right, I'm going to scroll back to where we were, and then let's start putting this model together. So where do I need to start? What do I need to do to begin with my pipeline? What's my first piece of code here? Based on what we did earlier. Thank you, CC. I got to make my pipeline. Trevor, you're on the money, right? So I'll make my pipeline and I'll just hit enter once so that there's some space between it. And then the first thing I'm going to do is I'm going to put in my one-hot encoder. And what's that argument I always set to true? Use cat names, exactly. So I'll do use cat names and I'll set it equal to true. And then I'll put a comma. And then next, after you do your one-hot encoder, we're going to put in our simple imputer. And I'm just going to use the default here. By default, it's going to fill in the missing values with the mean value for that column. So whatever the average was. We can do different things. We can do the mode like Zunaira was talking about. There are lots of different options, but we're just going to keep it default, so we don't need to do anything. And I'll put a comma after that. And then we have the one-hot encoder, simple imputer. The next thing is the standard scaler. So we can take all those numbers that have different ranges and squish them all together. And then last but not least, I'm going to put in my logistic regression. So I have 1, 2, 3 transformers, one-hot encoder, simple imputer, standard scaler, and then 1 predictor. And then once I've done that, what I can do is do model.fit, and I'll do xtrain and ytrain. And then I'll run my code. Excellent. So give me a thumbs up if your code is running. All right, I see some thumbs up. Excellent. If you're having bugs, that's all right. So now I have my model. It's rocking and rolling. And what I'll do if I scroll down is I can check my metrics. And what I'll do is I'll check both my training metrics and my test metrics. Or excuse me, not my test metrics. I'm going to check my validation metrics because I don't have the answers for my test metrics. So I'll hit Shift and Enter. And what I can see are two very wonderful things. I can see one, my training accuracy and my validation accuracy are about the same. My validation accuracy isn't quite as good, but that's to be expected, but they're in the same ballpark. And then the other thing I can see is that this 79% is way higher than the 62% that I had for my baseline. So I can see that my model is beating the baseline. The baseline is beaten. Now, any questions about this code and what we've done so far? So Naira's shaking her head. Trevor, Devin,
The
Carlos?
simple imputer, that was the one that put the value, the NaN values, or filled the null values.
Correct. So let's actually label these. I'll go fill NaN values with column mean. And this will be encode categoricals. The standard scaler rescales all features. And this is so that their mean equals 0 and their standard deviation equals 1. And then we have the logistic regressor. So you're exactly right, CT. Beautiful. All right. Now we have about 10 minutes left. And so what I'm going to do is the last piece I want to show you guys gets to CT's question from yesterday or from earlier today, which is how do you troubleshoot what's happening in your pipeline? Well, let's create something here. Let's see here. What number are we on? 6. So 6, let's go to communicate results. And what I want to do, this is a good thing to keep in mind because you never know. It could be on a sprint challenge sometime in the future. These things can happen. So let's take a look at it. What we need now is we need our coefficients and we need our features. But here's the issue. I can't go model.coefficients or coef because my model is not a linear regressor predictor, it's a pipeline, right? My model is that box in which all of my transformers and my predictor are located. And so what I need to do now is I need to go into my pipeline and pull out my my logistic regressor and get the coefficients from my logistic regressor. So let me show you how to do that. I'm going to go to model. And then the next thing I'm going to do is I'm going to do named steps. And what named steps does is you remember those names that we saw in the tuple? Logistic regression, one-hot encoder, simple imputer, standard scaler. That allows us, in the same way you would access something in a dictionary, that allows us to get that regressor. So for example, let's just do a quick example here. If I look at the type of model, it'll tell me it's a pipeline. If I then look at the type of, if I go into name steps and get the logistic regression, it's going to tell me, no, it's a logistic regressor. So now I'm inside the pipeline. I've got the logistic regressor. And then the last thing that I need to do is once I have that logistic regressor, I can do coef. And now I have my coefficients because I can see that the type that comes back is an array. And if we look at that array, what we'll see is here are my different coefficients. So these are my coefficients that I now have. And actually I can see here that these are like inside. If I look at the shape, check out that there's like a double bracket here for whatever reason. I can see there's 113. That's not what I want. I can go in and grab just the first item there. That should give me what I want. There we go. That's the list that I want. I only see one set of square brackets. Beautiful. So I'll grab that and I'll paste it in here. Now I have my coefficients. And then the next thing I need are my features. Now we did one hot encoding here. So we need to get those feature names, those new feature names from our one hot encoder. So again, I can't do model get feature names. That's not going to work. What I need to do is I need to use name steps, and then I need to get my one hot encoder, and then I can get my feature names. So here are my feature names. So always think kind of like, where am I? Am I inside the pipeline? Am I outside the pipeline? Using type here is going to be very helpful, exploring the data types. So now I have my coefficients and I have my features. Let me delete this one here because we don't need it anymore. And then what I can do is I can create something called, feature importance, and I can say PD series. And once I have the series, I can put in the coefficients as my values. And for the index, I can put the features. And this is going to be the same code that we used last time. And this is a linear model. So the coefficients are going to be both positive and negative. And so what I'll want to do is I'll want to definitely sort those values. And I want to sort them by their absolute value. So I'll do key.abs. And now if I look at feature importances, I can see here are my coefficients. And what I can next do is do feature, and I can plot them. I'll do kind equals bar H. And if I look at this, now I can see what was important in predicting survival on the Titanic. So what does this tell us about predicting survival on the Titanic? What does this tell us about what's the most important thing when it comes to survival on the Titanic?
If you were a first-class female and a couple other things, you had a higher likelihood of surviving.
Exactly. So what this is telling us is first, CT, you said women and children first. Well, it looks like women, right? Being a woman allowed you to get on the lifeboats before a man, perhaps. The other thing is we can see age. We can see that if you're in third class, that greatly decreases your probability of survival. And if you're in first class, it goes up. And then also age. So as your age goes up, this is being multiplied by a negative number, your survival prediction goes down. Fascinating. Also, it really helps is if you embarked, or where you embarked, I guess. Okay. We've done it.
So how do we use are we going to use the test data that's in GitHub to validate our results, or do we not have enough time to do that?
Let me talk about how I would. So the first thing that you would do, I'll touch on this briefly. We're not going to get to see the final answers because we don't have them, right? Our test data doesn't have the answers. We'd have to submit them somewhere. But what I could do is I could say model.predict, and I could do, for example, X test. And what that would give me is an array where the zeros would be my prediction that they didn't survive, and the ones would be my prediction that they did survive. So I would take these predictions and put them into some sort of format that I could then submit to like a data competition, and then they would tell me what my accuracy was. And there's a stretch goal about this as well, so keep that in mind. Speaking of stretch goals, we have a couple things that we need to do before we leave for today. The first thing is I want to share with you guys the attendance code. So let's see here, full-time DS25. Boy, can you guys believe it? We've almost made it to the end of sprint 1. So I'm putting the link here. And Devin is asking, by the way, does embarked NAN, let's go back to this guy, does embarked NAN mean that they didn't embark? Rather what it means, let me just run this cell again. Rather what it means is not if we didn't know, so this is the one-hot encoder, and it's basically putting in a 1 if there's no information about whether they survived or whether they embarked or not. So perhaps what it means is that there's having no information as to whether they embarked or not indicates survival. Maybe that means because they never embarked at all. We would have to do a little bit more investigation, but that is a possibility. Okay, so we're going to open this guy, Logistic Regression attendance. And the code for today is, get ready, 3647. 3647. 3647. The Powerball is 32. 3647. And for today's class, or for today's module project, you all are going to be working not on Titanic data, but on burrito data. So we're going to go a little bit lighter here. Not lighter in the sense of burritos are pretty heavy food, but in terms of mood. All right. And so what I want you all to do is I've given you a wrangle function for this burrito data set. And your goal is going to be to make a predictor that will predict whether a burrito will be rated great or not. So whether it will receive a rating of 4 or above or below 4. Now, there are a couple things that you need to do. You're going to need to work a little bit with this wrangle function. There's going to be you're going to need to do a little bit of encoding of some funky variables. There's a stretch goal as well. And then you're going to be doing the data split that we saw today. And then you're going to do actually a time series split, which we saw yesterday. You're going to need to establish the baseline accuracy, like we saw today. And then you're going to need to build a logistic regression model. And in fact, that logistic regression model is going to be the same series or the same format or have the same components that we saw in our Titanic model. And then, of course, you'll check your metrics. You'll put together a horizontal bar chart like we've done here. And then I would love for you guys as a stretch goal to talk a little bit about the difference between what happens when you put in .predict for your model and .predict proba. So look into the documentation, do a little coding, and then give me your written answer in the notebook. One last thing, and then I promise I will let you guys go. I added at the beginning of class a couple questions that will help you prepare for the sprint challenge tomorrow. And so what I want you guys to do, they're in Slack and they're also in this notebook. I want you to go through them. And if you can answer yes to the question, you're good. If there's a question where you're like, I'm not sure, or what's going on, that's a good signal that you should come see Cece during Q&A today at 2:30, or see Isaac today at 5, or tomorrow between 6 and 8. For the sprint challenge will be available starting at midnight tonight. All right, and you'll have until 5 o'clock tomorrow to finish it. That deadline is firm. However, if there's a family personal emergency that's going to keep you from completing it, please let me, Cece, or Dante know ahead of time, and so we can know and make a contingency plan together, us and you. All right. Well, listen, guys, I would wish you good luck on tomorrow's sprint challenge, but I got to be honest, I don't think you need luck. I think you've been putting in a lot of work this week, and I think it's really going to pay off. All right. So I will see you all tomorrow when we'll all be available Cece and I will be available starting at 8 a.m. for questions. There'll be a Q&A for the sprint challenge at noon, and then tomorrow at 2:30, Cece is going to lead a special edition of something we call 60-minute models. And what 60-minute models is we just pick a random data set, a data competition, and we see if we can build a model and make a prediction and submit those predictions within 60 minutes. Sometimes we do, sometimes we don't, but the important thing is that we always try. All right, so keep that in mind, and I will see you all, in the funny papers. All right, so stay safe, take care of each other, and happy data science. Bye-bye, guys.